Now I'm getting hungry. I might make the chickpea again. I hope I don't owe money, but I will go to Jackson Hewitt, Walmart. Um, what? What are you, what's wrong, John Foster? I do make a mean chickpea. You're an iceberg, you don't do taxes. So, yeah, yeah. So I'm giving you guys sort of a, announcement right here. If you want to do your taxes and get a discount filing your taxes with TurboTax, the deadline is February 28th, midnight. If you file before then, it will be discounted. And so I did. And today was the day for that. Rose drowned my taxes. She making filet mignon rich. She making chickpea rich. February 28th, I don't have that much time. I gotta work and stuff. Okay. Filet mignon. Okay. So, what is the current status? All right. Before I forget, I keep forgetting. So, Reese, you asked about the quantum property of spin. I thought about it a little bit more. So basically, for all the particles that we discuss under particle physics in the standard model, like say, for example, electron, positron, which is the anti-particle of electron, neutrinos, muons, taus, basically, in quantum mechanics, each of the particles have certain properties. Like the way to think about it is that they have certain properties. Some of the properties might be more popularly known than others, but basically spin is one of them. So mass is one property that will distinguish a particle. Charge is one property. Spin is one property. So those are the different properties that you might come across, and the spin of fermions is different than the spin of bosons, and also depending on so let's just say once you get, for example, an electron, depending on its mass, charge, and spin, you will know that it's an electron. If you compare it to the positron, which is its anti-particle, then the mass will be the same. The spin might be the same. I mean, there's only two possibilities. It'll be one of those. The thing that will be different is the charge. So that's kind of something that will distinguish or make you be able to, that's what makes the particle distinct from each other. And the particle's state, it's kind of like the quantum state of the particle is given by those things, the mass, the charge, the spin. In some cases, there is another property as well, depending on if it's a quark, right? So once again, just a quick recap. The particle family, there's three types of particles. There's leptons, quarks, and bosons. Once again, an example of a lepton is the electron or the muon or the tau or the neutrinos. Actually, there are three flavors of neutrinos that we have talked about as well. So that's in the lepton family, Lepton. Then there's the quark family of particles. Quarks are another whole type of particle, and examples of a quark would be the up quark or the down quark, things that make up stuff like our protons and neutrons within an atom. So subatomic particles, or really the nucleus of an atom, has more particles in it, protons, neutrons, which break down further into these things called quarks, which are in that family. Lastly, we have the boson family of particles. This includes things like the photon. The photon, which is, of course, light, is the particle nature of light, is a photon, is an example of a boson. All of these particles that I just now mentioned, so all of the above, when you write down the quantum state of a particle, you will have things like its mass, the charge, and the spin. And in the case of quarks, there's one more property. But hopefully that kind of makes it a little bit more clear what I meant. Basically, think of it as an identifier. If I tell you the mass, like say if you didn't know that it was an electron, but I told you its